go ahead and give a little bit of a an introduction about this, because I found this fascinating, Morgan, about, you know, and I never had thought about this before, but the whole idea of Venus and Mercury being much tighter parts of the orbit of the sun. And of course, when the sun goes down and the Earth basically is supposedly turning away from the sun, how are we able to see Venus and Mercury at nighttime? And I found that to be a very, very interesting proposition. And this is where I'm spatially challenged, because I'm not very good at visualizing this, but I know you and Jaren are. And so I was hoping that, you know, you guys would talk about this a little bit today, because I find it fascinating.
Okay, so this is a little bit more to scale model of the image that we had before, which was, do I have it up here anywhere? Yeah, this one here. So this was not to scale. This was just sort of to convey a point. But this one here is a little bit more to scale, with the sun being an inch in diameter, representing 1,000,000 miles. And I know that's not exact, but it's pretty close. The alleged orbital path of Mercury, the average distance to the sun is, well, let's see here. I've got it. It's going to be half of this number here. So about 36 million miles from the sun, radius on average. And then you've got Venus, which is on average 67 million miles from the sun on average. Now, just keeping in mind that we've got, you know, the little tiny Earth here receiving a wall of light coming in from the sun, and you know, this whole side, this yellow side of the Earth, would represent the daytime side. And as you start to, you know, revolve away into the nighttime side, your line of sight is going to be a tangent to the curve of the Earth, right? And so if you look at this in terms of Venus, I've sort of changed my position on Venus a little bit, that line of sight is questionable. There may be certain circumstances where Venus may align to that line of sight. But even in that situation, it would be so many millions of miles away from Earth that its angular size would render it invisible. Not to mention, we'd be dealing with an indirect reflection of light towards us. So Venus should not be visible, period. Because again, it would be aligned to the day side of Earth at all times, no matter what. And even if you could get that line of sight towards the horizon, you know, just after dusk or just before dawn, it would be too small to see. Now, Mercury, on the other hand, I believe is a slam dunk. And again, this is all sort of an extrapolation or a deeper dive into the Jaranism effect, where, you know, technically visible space should be way over here during the winter, and visible space should be way over here during the summer, yet we can see all the same constellations all year round. So this is just looking inwards towards the solar system. And, you know, Mercury should simply never be visible, because we can't see the planets during the day. And according to this tangent line of sight towards visible space, Mercury's path of orbit would never intersect with that line. Now I did, well, this diagram here just sort of shows the, this being the ecliptic, which is the path of orbit that the Earth allegedly orbits the sun. Venus and Mars are allegedly offset to that ecliptic by a few degrees. I think it's 7 and 3 or something like that. So not by much. But in fact, you know, that diagram should look more like this, because the sun's going this way as we orbit it this way. So that's a whole nother conversation. This gives you just sort of a better side view of what's going on, another side view during the summer. But there was one, let's see, okay. Pertaining to the moon, which is again sort of shown, where'd it go? I'm using too many programs here, I swear. Yeah, but pertaining to the moon, the full moon should only be visible during the nighttime due to this same principle. You know, you've got your day side of the Earth being in towards the sun, no matter where you are in its orbit, or no matter where you are in its spin, allegedly, day side is always this way towards the sun. Therefore, the full moon should only be visible at night. And I've actually personally taken some footage recently on August 19th of a full moon during the day. So this is, yet again, another physically impossible phenomenon in the heliocentric model. But one final thing I'd like to mention is that Mercury, if I can find my thing again here, where'd it go? It's back up here. Mercury at its nearest point is 77 million miles away from the Earth. So that would be like, the shortest distance between 2 points is a straight line. So at its nearest, Mercury would be 77 million miles away from the Earth with a diameter of 3,000 miles. Now, according to the laws of perspective and angular size, Mercury should disappear altogether from visible sight at about 10 million miles. So from about this far away, right? But yet we can see Mercury plain as day when it should be, invisible just due to the distance alone. Now, assuming that somehow we could get this tangent line of sight towards visible space, just after sunset to reach this, which is impossible. But even if we could do so, it's going to be much further than 77 million miles away. And again, you're going to be looking at sort of a crescent Mercury. You're not going to be looking at a full Monty reflection of the planet. So it is my contention that the fact that Venus and Mercury are visible in the night sky are damn good proof that the heliocentric model doesn't actually work. And I've got just a final picture here somewhere that shows, where's my magnifier, that shows Jupiter, too much, Jupiter, Mercury, and Venus visible in the same sky 30 minutes after sunset, which means they would have, continued to be visible for about another 30 minutes. This one image to me is excellent proof against the heliocentric model, simply because we can see Mercury and we can see Venus and Jupiter in the same sky. So that's pretty much my position on that. It's being debated a lot, but me personally, I see it as an excellent proof against the heliocentric model. Oh, and same thing with this crescent moon at night. It's the same sort of thing. If you look at this diagram, crescent moons should only be visible during the day. So, there you have it. A couple of good images that don't align with the heliocentric model, which is, the more we dig, it seems like that's all we ever find is more and more images that don't jive with, what we've been taught.
And of course, the flip side of that also is that they don't work in the heliocentric model, but they certainly do work in the flat Earth model.
Yeah, absolutely.
So, again, and whether it's, and great, it's great that people are discussing it or debating it or whatever, because isn't that after all what we're trying to get people to do, right? Is to talk about this and, talk about the possibilities and get different viewpoints on it. And I always appreciate stuff like this because, like I said, this is the one area where I'm extremely weak in, is being able to visualize stuff like this. But to me, everything you just said makes perfect sense. Now, I'm sure that somebody is going to come back and say, well, no, we're going to do this many miles and here's the angles, this, that, and the other thing, and try and explain it otherwise. But, and if so, that's great, because, if it can be debunked, by showing a good geometric model, that's great. But from what I'm seeing, I don't think that's going to happen either.
Well, and the fail-safe, though, is even if a line of sight could be achieved, the angular size of Mercury especially would render it totally invisible at that distance. So that, to me, there's really no way to debunk this.
Yes, that is huge. And I'm sure if Kirk was here, Curious Life of a Flat Earther, he would agree with that 100%, especially with all the work that he's done on angular size. And I agree. It would simply be invisible. Even under the best of viewing conditions, the angular size would simply be too small for us to be able to see it.
Well, right, and the only way that you could possibly get a full lit Mercury is if it was on the total opposite side of the sun at its furthest distance, which is like 133 million miles. So of course you'd never see it because it would be on the other side of the sun during the day, and it would be 133 million miles away. So, yeah.